Hi guys, today we're going to be looking at sketching cubic functions. Now when you sketch a cubic function, the first thing you need to know is the shape. And how you're going to know the shape is by looking at your a value. So if your a value is positive, right, then your function is going to look like this. And if your a value is negative, your function is going to look at this. The second thing we're going to look at is your stationary points. To get our stationary points, we find our first derivative and equate to 0. We then sub back into original, right? And your stationary point is basically what looks like a turning point from your parabola. So these would be your stationary points. The next thing that you need is your x-intercept, and to find your x-intercept you're just going to let y equal 0, and then you're going to solve, and then you're also going to need your y-intercept, which you just let x equal 0 and you're going to solve. The last point you need is your point of inflection, and for your point of inflection you're going to find your second derivative and equate it to 0, and then you're going to sub into your original. Okay, now let's put all of this into practice. When I like doing this section, what I like doing is making sure I have headings for whatever I'm doing. So we're going to do this question here A, and with doing A, the first thing we're going to look at is the shape. So you can make a heading, say shape, and here we have A is positive, so we know the shape is going to be like this. So we know what our shape is. We can put that aside. The next thing we can look for, what is our y-intercept. So our y-intercept, we're going to let x equal 0. So if I said y equals 0 cubed minus 3 into 0 squared, it is going to be y equals 0. So that would mean our y-intercept here would be 0 and 0. So we also know one of our x-intercepts would be 0 and 0. So now we have our y-intercept. It's 0 and 0. The next thing we need to find now is our x-intercept. So I will put a heading here, our x-intercept. We're going to let y equal 0. So we'll have 0 equals x into x squared minus 3. Oh, we can actually take out x squared here as a common factor. We have x squared into x minus 3, and then we have x equals 0 or x equals 3. Now we're going to substitute that 3 into the original, and that's going to look like 3 to the power 3 minus 3 into 3 squared, and that's going to give us the value of 3 to the power 3. I'm just going to put that into my calculator. I got 0 again, so that makes sense. So we will have now 3 and 0. So our x-intercepts are 3 and 0 and 0 and 0. You'll see no matter what value you get here for your x-intercept, it will give a y value of 0 because that is your x-intercept. But you can go and try it. So now we have our x-intercept. We now need to find our stationary points. So we'll write stationary points here. we'll say what is our first derivative, and our first derivative here will be 3x squared minus 6x. We're going to equate that into 0, and 0 is going to equal x into 3x minus 3x, yeah, and we'll get your x minus 2. So then we know our stationary points would now be x equals 0 or x equals 2. So this one of our points is going to be 0 and 0, and another one of our points here is going to be 2, and we're going to find what is the f of 2. We're going to sub that into our original. So if I put that into our original, I have 2 to the power 3 minus 3 into 2 squared, and that'll give me negative 4. So I have negative 4 here. So we have our stationary points, and the last thing we need to find here to complete this is our point of inflection. So we're going to make a heading for that, for our point of inflection. For our point of inflection, we're going to find the second derivative. We're going to equate that to 0. So let's first see what our second derivative is. We're going to look at our first derivative and derive it again. So I'm going to have 6x minus 6. I'm going to say 0 equals 6 into x minus 1. Then I'm going to have x equals 1. So then I'm going to find what is f of 1. Put that into my calculator, and I'll get 1 minus 3, which will be negative 2. So this point here is 1 and negative 2. We now have all our points needed to draw this. Let's draw our axes. Right? So what are our key points? So we have 0, 0. That's a point. Another x-intercept is going to be 3 and 0. Another point we're going to have for our stationary point is 0 and 0. So that means our graph is going to turn here. It's going to turn again at 2 and negative 4. So that point there is going to be 2 and negative 4. So this is another one of our stationary points right here. And then the last thing we need is our point of inflection, which is at 1 and negative 2, which would be about here somewhere. So we have all the key points in this function. We know the shape is going to look like what we have here in our corner here. So I'm going to draw this. I'm going to start here. It's going to go through here, come through here, turn back here, and then go all the way through 3. And just like that, we've drawn the graph. So that point there's 0 and 0. We don't really need to mark it. This here is going to be 1 and negative 2. Join in for the next video where we're going to look at how do we draw a cubic function with a negative a value. It's the same process. All that changes is the shape, but let's go through it again so you guys can see another example. To get a better hang of this, I always recommend practice more, do more examples, and I hope this was helpful. We're now going to look at draw in our cubic function with a negative a value. So we're going to follow the same process, and here the shape is going to change. That's the main thing in this process that's changing. The rest of it is procedure, and we're going to do the same thing. Now our shape is going to be like this. Okay, so we have our heading for our shape. The next thing we're going to look at is our y-intercept. We're going to let x be 0, and if I let x be 0 here, my y-intercept is going to be 0 and 0. You can sub it in and check that out. The next thing I'm going to look at is my x-intercept, where I let y equal 0. So I'm going to say 0 equals negative x to the power 3 plus 6x squared minus 9x. And I can take a common factor here out as x. So this is my x-intercept. So I can take out negative x as a common factor here, and I'm left with x squared plus 6x minus 9. And for this x-intercept, I'm just going to factorize this, and I'll have negative x into x. This is going to be when I factorize this 3 and 3. Oh, this sign here and this sign here is going to change. So this is going to be a minus, this is going to be a plus 9. So I'm going to have minus 3 and minus 3. So here x equals 0 or x equals 3. So I'm going to find out what are the x-intercept values, and I know one of them is going to be 0 and 0. The other one is going to be 3 and 0. Remember, for our x-intercept, the y value is 0. We let it be 0. So now we have our x-intercepts. We're then going to move on to our stationary points. Now, this is where your new metric work comes in, because we're going to find the first derivative, and I always recommend putting headings for this. So my stationary point here, I'm going to find my first derivative, so it's going to be g of g prime x. I'm going to have negative 3x squared plus 12x minus 9. And I can take out a common factor here of negative 3 into x squared minus 4x plus 3. Okay, and then I'm going to now equate this to 0, because that's what we need to do to find our stationary points. And I'll have negative 3 into x, 3 and 1 minus. So here x equals 1 or x equals 3. So I need to find out in my original what is the value for g of 1. And if you go and put that into a calculator, you're going to put negative open brackets 1 close brackets to the power 3 plus 6 open brackets 1 close brackets to the power 2 minus 9 times 1, which will give me negative 4. And then here I will have the g of 3, and we're going to put the same process into our calculators. And what we will get here is 0, just like what we had earlier on the top. So that is going to be one of our stationary points. So I'll have negative sorry, I'll have 1 and -4, and I'll have 3 and 0. The last thing we need to find here is our point of inflection. So to get our point of inflection, we're going to look at our second derivative and equate it to 0. So our second derivative here is now going to equal -6x plus 12. 0 equals -6 into x minus 2, and then I'm going to have x equals 2. I need to sub this into our original and see what the g of 2 is, and that will give me, let's just put this in our calculator quickly. That'll give me -2. I now have all these key values, so I know this point here is going to be 2 and -2. So we now have all our key values. We're just going to draw our axes and plot these points down, and we can have our function. So if we look here, we're going to have this axis. Okay, we have 0 and 0. We know that's a point. We know our x-intercept. So at 0, 0, we can just make a dot there. Our x-intercept is going to be 3. So at 3, we'll have another point there. Our stationary point is 3 and 0. So this is going to be one of our turning points. So we'll put a dot there. Our stationary points, which is the accurate term, 1 and -4 is another one of our stationary points. So we have 1 and -4. Okay, and at 2 and -2, which is here, is going to be our point of inflection. So we're going to look at the shape, which is very important when drawing these. We're going to look at our shape, and then our shape is going to go from here all the way down through here, up through here, and turn back here. And then now we can put this value here in of 2 and -2. So this here is 0 and 0. I hope this video was helpful. This is how you can draw both the positive a value and the negative a value. The positive a value is my previous video. I hope this is helpful, and this is how you can do it without putting it in your calculator to solve for the values, where you factorize it manually. If you like any other videos, please let me know, and don't forget to like and subscribe, comment and share. All the best. Practice, practice, practice.